For as long as we've looked up at the night sky, humanity has asked one question that transcends time, culture, and technology. Are we alone in the universe? The idea of alien life has captivated our imaginations, from ancient myths of gods descending from the stars to the modern wonders of science fiction. But in the realm of science, this question is not just speculative, it's a matter of possibility. As we've explored the vastness of space, our search for alien life has become a quest grounded in discovery, filled with both triumphs and uncertainties. In our galaxy alone, there are over 100 billion stars, many of which have planets orbiting them. The numbers are staggering. And if even a small fraction of these planets fall within what we call the habitable zone, the region where liquid water can exist, then the odds seem to favor life beyond Earth. So, with the universe teeming with potential, why have we not yet found definitive evidence of alien life? The search for extraterrestrial life is not just about finding something new. It's about answering some of humanity's deepest questions. What is life? How did it begin? And are we, as a species, truly unique? As scientists around the world work tirelessly to uncover the secrets of the cosmos, the question remains, how close are we to finding alien life? To begin the search for life beyond Earth, we must first look to the stars. For the last few decades, scientists have been looking for planets outside of our solar system, known as exoplanets. With more than 4,000 of these planets already discovered, the possibilities seem endless. Exoplanets are worlds that orbit stars far from our Sun, and some of them reside in what scientists call the habitable zone, an area where temperatures are just right for liquid water to exist. This is critical because, as we know from life on Earth, liquid water is one of the essential ingredients for life. The Kepler Space Telescope, launched in 2009, became the harbinger of this new age of discovery. With its unprecedented ability to detect the faint dimming of stars caused by planets passing in front of them, Kepler revealed thousands of exoplanets, many of which are similar in size and distance from their stars to Earth. Among them, scientists found some that seemed to mirror the conditions that might support life, piquing the hope that we might not be alone. The Transiting Exoplanet Survey Satellite, TESS, is continuing this search, expanding our knowledge of the universe's diversity. It's found thousands more planets orbiting stars, some of which might harbor conditions that are conducive to life, whether microbial or more complex. But as hopeful as this sounds, finding a planet in the habitable zone is just the first step. While the discovery of exoplanets in the habitable zone is an exciting leap, it raises a deeper question. What kind of life could survive there? The simple answer is life as we know it. But we must remember, the universe is vast, and life might take forms we can't yet comprehend. Earth's ability to support life comes from a delicate balance of factors: its atmosphere, temperature, chemical composition, and a magnetic field that protects it from harmful radiation. For alien life to thrive, we would need to find a similar set of circumstances: an atmosphere that can support liquid water, a stable climate, and the necessary chemical ingredients. With instruments like the James Webb Space Telescope, JWST, on the horizon, astronomers will be able to peer deeper into the atmospheres of these distant planets. The JWST will provide a glimpse into their chemical compositions, revealing gases like oxygen or methane, signs of biological processes, or perhaps even the trace elements of life itself. As we study these distant worlds, we also need to consider the possibility of alien environments radically different from our own. Could life thrive in an atmosphere of methane, or in the boiling waters of a distant ocean? Or might it live in extreme cold, like the extremophiles found in the frozen waters of Antarctica? While searching for microbial life may seem like a modest goal, the discovery of even the simplest organisms beyond Earth would have profound implications. Microbes are the foundation of life, and they are far more resilient than we might imagine. On Earth, microbes are found in some of the most extreme environments imaginable, from the deepest ocean vents to the hottest deserts and the icy poles. Their resilience shows that life can survive under conditions once thought uninhabitable. This knowledge fuels the search for life on Mars. Billions of years ago, Mars had flowing rivers and lakes. Could ancient microbial life have thrived there before the planet lost its atmosphere? NASA's Perseverance rover is currently exploring Mars' Jezero crater, searching for signs of past life within ancient Martian rocks. But Mars is just one possibility. Moons like Europa, one of Jupiter's largest satellites, present another tantalizing target. Beneath Europa's frozen shell lies a vast ocean, and scientists believe this ocean could harbor the right conditions for life, perhaps even microbial life thriving in an environment isolated from the sun's light. NASA's Europa Clipper mission will soon launch to explore this moon in greater detail, giving us the best chance yet to answer the question: does alien life exist in our own solar system? But what about more advanced life? Civilizations that might be capable of communication, technology, or interstellar travel. This is the question that leads us to the search for extraterrestrial intelligence, or SETI. SETI scientists scan the cosmos, listening for patterns in radio waves or light signals, hoping that one day we will hear something unmistakable, a signal from an intelligent civilization. The Arecibo Observatory, once the largest radio telescope in the world, and the Green Bank Telescope are two of the most important tools in SETI's search. For decades, these instruments have listened for signs that might indicate a distant civilization's presence. While we've heard many strange signals, none have yet provided the unmistakable proof we need. Many of these signals turn out to be natural phenomena, pulsars, quasars, or even distant stars. But the possibility that a message from another intelligent civilization might be out there, waiting to be detected, keeps the search alive. Yet, despite the promise of discovery, there's an unsettling idea that haunts the search for alien life: the Great Filter. This is the hypothesis that suggests that, although life may be common in the universe, advanced civilizations are extremely rare, perhaps because something in the evolutionary process prevents most from reaching the stage where they can communicate across space. The Great Filter could be any number of factors: an event that wipes out civilizations before they can leave a mark, or a critical step in evolution that only a few species can achieve. If the Great Filter is ahead of us, we may never become the kind of civilization we dream of becoming. If we've passed the Great Filter, if humanity is one of the rare civilizations that made it through, it might explain why we haven't found any signs of others. But the truth is, we don't know. This brings us to the Fermi paradox. Given the vast number of stars and planets in our galaxy, why haven't we encountered any signs of life? Where is everybody? The paradox challenges our expectations. If intelligent life is common, why do we see no evidence of it? Some argue that alien civilizations might be avoiding us, or perhaps they're so far advanced that they are undetectable. Others suggest that the sheer scale of space and the limitations of our technology may be preventing us from making contact. So, how close are we to finding alien life? The search is ongoing, and with every new discovery, we get one step closer. We are exploring worlds beyond our own, sending probes to distant moons, and listening for signals from across the galaxy. Yet, the mystery persists. Perhaps we are not alone, and perhaps we are not ready to meet the cosmic neighbors we seek.